Hi everyone, in this video I'll show you how to graph an ellipse when the center of the ellipse is not at the origin. So recall that the general equation for an ellipse is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1, where the center is hk. So we have this equation of an ellipse to graph. X minus 5 quantity squared over 25 plus y plus 1 squared over 9 equals 1. So let's begin by plotting the center. The center will be at 5, negative 1. So let's plot that 1, 2, 3, 4, 5, negative 1. And let's also list that, because a lot of times you'll be asked not to just to graph your ellipse, but to list these points. In this case, the larger number is under the x variable, so that tells us it's going to be a horizontal ellipse. So that number, the 25, is our a squared. A squared is 25, meaning a equals 5. Our b squared is 9, meaning b is 3. These numbers, our a and b, are going to help us graph our ellipse. So how does that work? We go from the center, we're going to go 5 units horizontally in both the positive and negative direction. So we're going to go 5 units negative direction and 5 units in the positive direction. 1, 2, 3, 4, 5. And with the value for b, we're going to go in the vertical direction from the center because that came from the number under the y. So we'll go 3 units vertically up and down from the center. 1, 2, 3, and 1, 2, 3. This will give us the overall shape of the ellipse. So now we can list some other important information. Notice that, okay, here's our major axis. It's going from this vertex to this vertex. And notice that this value is a, and this value is also a. It came from what we figured out here. So that tells us our major axis length is 10. 5 and 5. And then the minor axis is, think about that, what's it going to be? 6, right? Because we've got 3 this way and 3 that way. Now let's list the vertices. Most of the time, the vertices you'll be asked for will just be the ones at the ends of the major axis. So those points are 0, negative 1, and 10, negative 1. Just counting across here, this was 0, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then negative 1. Next, we need to think about the foci. I'm just going to list that here, so always remember that. You will always be asked for that with the ellipse. So how do we figure out the foci, and what are they? Okay, the foci will be points inside the ellipse on the major axis. And how do we figure out where they are on the major axis? Somewhere along here, but where? There'll be 2 of them, and the way we figure it out is we find a value for c, which is found by a squared minus b squared equals c squared. So make sure that's a minus. And some books will write this differently, and they'll have the a and b in different versions of the formula. The thing you need to remember, it's always going to be the bigger number minus the smaller number. So in our case, it's going to be 25 minus 9, which equals 16. So if c squared equals 16, then c equals 4. So to graph the foci, we're going to use that value of 4 to go 4 units on the major axis in the negative direction, which would be right there, and then 4 units in the positive direction from the center. So then we can list our foci. So this point here is 1, negative 1. And our other one is, okay, that was 5, 6, 7, 8, 9, negative 1. So the last bit of information we need to complete our ellipse is not going to be something we show on the graph, but it's a value we calculate. And it's the eccentricity. The eccentricity is a number that tells us how circular or how stretched out our ellipse is. And the value of E will always be between 0 and 1. So the closer it is to 0, the more it's like a circle. And the larger the number gets, closer to 1, it's going to be more stretched out. So there's a little formula for that too. It's E equals C over A. And so for our case, C we found is 4 and A is 5. So our eccentricity for this ellipse is 4 over 5. And my answer is complete.